It's time to build our classifiers. Okay, let's actually start by importing them all that we're going to use. Okay, first put in a new header, classifiers here. And you should be in the notebook that you were just working on, which is the one where we loaded the census data and split it into X and Y. Okay, so what are we going to import? Well, let's start with logistic regression. Try that one on your own. Do you remember? Yes, I sometimes forget where they're from. Where is it? Where it's from? We start with sklearn, and then dot linear model, and then it's an import. So start import, and then it's logistic regression. So start typing it in, and there you see it. And press enter. Okay, what else are we going to do? Well, each model that we made for regression actually has an analog for classification. And the reason why is because the input is the same, okay? And the strategy of the output is the same. You find a bunch of weights, and then you put them in a mathematical equation. The only difference is regression gives you like that straight line or hyperplane, and classifiers give you a split, right? And we saw how to do that with logistic regression. Well, go to the sklearn.tree library. You can also import a decision tree. If I tell you it's a decision tree, and you start typing decision tree, well, you've got two choices. And you should know which one to pick, right? It's, do you know? The classifier. It says classifier at the top of this notebook, but the point here is that why is it a classifier? Well, it's because Y, our specified target column, is all zeros and ones. Okay. Now, how do you know that? You do need to know that, right? I think there's something you could try. Let me actually add in here. If we go up one, oop, not what I meant. I want to put a new coding cell in here, and it's y.valueCounts. Okay, try that. Oh, look at that. It shows the spread of the data. It shows there are only two options, 0 and 1. It also tells us there are 24,720 people who make less than 50K and 7,841 who make more. So that data set's a little imbalanced, right? It's a 3-to-1 ratio. There are data sets that are much more balanced by that, which is its own kind of advanced topic. But that's okay. Okay, so that's how we know it's a classifier and we need all classifiers. You can always check your Y value counts to find that. Okay, what else do we have? Well, recall that we used XGBoost. It was from the XGBoost library. Import Xgb, and look at the options. There's two. There's an Xgb Classifier and an Xgb Rf Classifier. Last time we did the Xgb Regressor and the Xgb Rf Regressor. So let's do both this time as well. Xgb Classifier and Xgb Rf Classifier. So recall, decision trees are like games of 20 questions. You're splitting the data each time to get ideal results. XGBoost is a bunch of decision trees learning from the errors, and then they're a random forest. The random forests are in the sklearn.ensemble library. Okay, so you can import the random forest. And again, if I tell you it's a random forest, once you start that typing random, you know what to pick, right? Look at your options. It's a classifier, so you pick random forest classifier. Okay, so we're going to use these 5 different models to build machine learning models to score them to see how they do with each other. Now, recall that decision trees give 100% accuracy without splitting the data, and this does not have a separate training and test set. So let's go ahead and actually split the data. Okay, I want to say what I'm doing here so that we're all aware. Okay, check, target column values. Right, that confirms classification. And here we're importing classifiers. Get the hashtag. And now we're going to do train test split. Okay, let's do a new coding cell. And so from sklearn.model selection, import train test split. Okay, Now we're going to split it. So import train test split. And then, this could be its own line. Split the data. We've already got our x and y. We're going to split it. So recall how to do that. X train, comma, x test, comma, what's the 4 tuple here? Y train, comma, y test equals train test split. Bit of a mouthful here. X, comma, y. All right. Run that. And now we can do it properly. So let's first do logistic regression, and then we'll build a function to do them all. All right. So what do we need to do first? We've already imported it. So the next step is to initialize the model. So give yourself a variable, right? Call it model. Set it equal to the default logistic regression. Same steps as before, with the difference of the training and test sets, okay? So now when you fit the model, recall that's model.fit, it's not just on X and Y, okay? It should be on X train and Y train. And then when we score the model, right? Again, not on just X, Y, what should it be on? Can you tell me? X test and Y test. Okay, let's try that. Name is not defined. Did I not type it in right? Did I run? Sometimes if you have issues, you can always go to runtime, restart and run all. Let's try it again. Okay, no, it worked. Got 80%, which is very comparable to the last time. So what does this still do? I'm going to give it a text comment. Build and score a logistic regression model. Now what we want to do next is write a function with model, let's just say classifier, be more specific, as input and score as output. Okay? Go ahead and try that on your own. See if you can do it, right? We spent a lot of time working on functions. We did one like this for regression. So I bet a lot of you can do this now. Keep me in the background. I'll jump in case you need help. So you've got to define your function first using the right Python syntax and naming it. And there's never a right or wrong name, right? Just something that should make sense with what we're doing. And your input should be a model, okay? When you input it, I think it does initialize it, so you don't need that extra step. So it's not actually much. I can just actually copy in what I did above, all right? And I can just return the score. It's deceptively short with so much going on behind the scenes there. Okay, so I've got a function up. Go ahead and get yours up. And again, it doesn't have to be exactly the same. The point is it's got to have a model as input. It's got to fit it on X train and Y train. It's got to score it on X test and Y test. Okay. And now I can go through and actually run it on the different models, like the decision tree classifier, which I'm going to try first. So I enter it in there. Okay, when I started typing, call that prompts decision tree classifier. So I say yes, but then you need the parentheses. Let's see, does it work? It does, and it did a little better than logistic regression, not by much. Logistic regression, by the way, tends to do better than linear regression on average. Okay, so let's see how our others do. Let's get the Xgb classifier. Go ahead and put them in one at a time. Okay, you don't need to wait for me. Put them in there, get your scores and compare them. And you may find that you get different scores than me, and you probably should because there's randomness involved, and we're going to take a look at that. So my Xgb classifier does much better. Got 86.2%. That's good. And we got the I'm going to go ahead and put in the Xgb Rf classifier now. That is not a common one, by the way. The Xgb Rf classifier. You saw why last time it did not score very well. Let's see how it does here. Now these are taking some time, right? Because, okay, so it's didn't do as well as Xgb Classifier, but it did better than Logistic Regression and the decision tree. So pretty respectable score there, 84%. Note they're taking some time as well because, you know, it's like 100 trees, and each of those trees is based on how many, what is this shape? You guys get this shape? Yeah, over 30,000 rows here, right? So it's got to fit the data. It's doing multiple iterations, right, to fit 30 plus thousand rows. You know, but 100 trees, so that's like 3 million, like 3 million like rows or something. It's a lot more entry points. And finally, I'm going to put in the random forest classifier, overriding that shape because I don't really need it. I misspelled it. Error here, it's always cool to look at the errors. It says name classifier is not defined. Well, I just ran the function multiple times, so I know I defined it. So, right, the idea would be, well, if this one isn't defined but the other ones were, what happened? I misspelled it. And it's, you know, if you look carefully, you can see it. Embrace your errors. Okay, so it's going through like an 80, very close to XGBoost, though not quite as good this time. 85, well, rounds up to 86%. Cool. Now, after you've run each of these, how many do we get? 5? I guess we could put logistic regression in it, but we have it above. I'm going to do something interesting. I want to do this again. I want to split the data again. We didn't talk about this. Like, we'll split it the same way. Let's see what happens. Let's see if we get different scores. So I want you to go back to the cell in your Colab notebook where you have the data being split. And what I want you to do is to run that coding cell again. So you go find it and press Shift Enter. I think let's do the first score. So last time it was 80.1989. It's going to be the same. No, it's 79.41, etc. Okay, I don't need to rerun the function cell because it's already been defined. But the data's been split differently, I think. So let's check out the others. I got a 0.811 here. I get a 0.808. So everything's a little less here so far. XGBoost got 0.8623. And this one took a little time. 0.8635. It actually does better, slightly better. The Xgb Rf Classifier was 0.8398. Does a little better as well, 0.842, etc. And then the random forest is 0.8559. It does a little worse, 0.8528. So this is interesting, right? The XGBoost models do a little better and all others do a little worse. Okay. Well, what if I do it again? I kind of want to do it one more time. Like I get something, I'm doing it again. I get something radically different or no? Yeah, it looks like not. I kind of want to, if I keep doing it, can I get something that's like completely different? Yeah, it looks like they're often the same. But like, look, there's an issue here. Can you spot the issue? What's the issue? I can tell you this. This data set must be relatively balanced because sometimes you can get scores that are quite different because it depends on which ones are the test set. Okay? So we're going to look at a better method for actually splitting the data to get even more accurate scores. Okay? But fabulous job building classifiers. There's so much to learn when it comes to machine learning. You get started, and there's more and more. It's a really exciting field, and it grows a lot every day.